Okay, so today is simply going to be a nice and easy course summary, course retrospective. We'll talk about the final, and then on Thursday, I'll bring an electronic form, the question bank, and we'll spend as much time as you want on Thursday to go over the as a review for the final exam. But every week I've been posting a weekly retrospective, which is kind of a little bit different. In software development, generally you do, a lot of companies will do agile software development, where you've got these predefined periods called sprints. Typically a 4-week sprint or maybe a 2-week sprint or something like that, where at the beginning of the sprint, you decide what you're going to work on for the next 4 weeks. You commit to that work and you don't change that work or change course throughout those 4 weeks, because context switching is actually really expensive, both for an individual and for an entire team. You can't have just a boss coming in and saying, drop everything, you're doing this now instead, right? Nothing ever gets done that way. So you have predefined periods called sprints where you commit to work at the beginning of that. This is what we're going to work on in the next 4 weeks. After that 4 weeks is over, we'll present what we've done, and we'll have a retrospective. What went well, what didn't go so well, and what are we going to change for the next sprint. This course has kind of been structured like that, in that you've had about 2-week sprints. Now, we dictated what you're going to be working on for the next 2 weeks, but we broke it up like that for a larger project, that you had a 2-week sprint where you worked on the database design phase. Then the next one you worked on part of the database interface, et cetera, et cetera. And so it built on each other. Each one of those phases built on each other throughout the semester. It's a little bit different from the weekly retrospective of what we did, what's coming up next week. But I still like to do these course retrospectives to know what to do better for next time. Again, you identify what went well, what didn't go so well, and what can be improved for the future. And you'll have an opportunity to do this. You have an opportunity right now to do this with the course evaluation. This is your opportunity to say what went well, what didn't go so well, and what can be changed for the future. What I'm particularly interested, not in the quantitative numbers, the Likert scale numbers, but the written feedback. Take some time as you're filling out the course evaluation to think about those 3 things and give a true retrospective. What can be changed for next time? Is there anything in the course that you felt was cruft, that could be cut without much of an issue? Was there anything in the course that you felt that should have been there or more explicitly been there, et cetera? Recall that I am giving a final exam bonus for the completion rate of that. I'll have the numbers later on, but I think that only 18 out of 99 people have completed that, and so you're up to a 1% bonus on your final exam right now. If 100% finish, if 99 people sit the final and 99 people fill out the course evaluation, then everybody will receive that 5% bonus on the final exam. So keep that in mind. That was now announced on Piazza several times, so make sure that you're paying attention to Piazza. It's a little bit late to give that advice, or to take that advice, but still continue to do it if you have been doing it. So my retrospective, however, what went well, what didn't go so well, and what can be improved for the future, is as follows. Just as a review of what we did, you had a full project. Unlike the first, say, CS1, where you had these self-contained weekly programming assignments or these self-contained problems for each one of the major assignments that you did, this one was actually a full-fledged project that built on where phases built on each other. You built a fully functional back-end database that served the business needs of this problem statement, et cetera. And you also had, you didn't do explicit front-end stuff like reporting it to a web page or something like that, but you did have front-end stuff where you produced a report based on all those business needs. Hopefully, along the way, you've gained some skills. Your soft skills, especially if you teamed up with somebody. Both successful and unsuccessful, those are still experiences that are valuable. If you worked well with your partner, great, and you had a back and forth, you learned how valuable it is to be able to bounce ideas off of each other, to review each other's code, to keep each other on task. That's the ideal situation. Maybe you didn't have such a good partner that they flaked out, or they left, or they left you hanging, or you ended up doing all the bulk of the work. That's still a valuable experience because you learn how to deal with that in the future. You learn how to, those interpersonal skills of being assertive with somebody else and saying, this is what needs to be done. If you can't hold up your end, then these are the consequences. Conflict resolution, basically, is what that is. Coordination with another individual, right? So hopefully you've developed those soft skills a little bit better. If you didn't work with anybody, you certainly got the opportunity to do so in lab because we had you paired up on a weekly basis. So even if you didn't do it on the project, you still got exposure to more teamwork, more soft skills to complete those labs. Hopefully you've expanded your toolbox. We introduced Java as a second, maybe it's your third programming language. Always be picking up a new programming language. Even if it's nothing major, even if you just fill out a bunch of hello world stuff to see what a programming language looks like. You're going to be doing that constantly. You're going to, even when you get into industry, you're in a job for a couple of years, you might be using 1 or 2 languages on a daily basis and learn those languages very, very deeply. But you'll find that if you only learn one language very deeply and you don't start exploring others, then you start to think like that language's paradigm. If you only ever do Java, you will only ever think in Java. And you'll never be able you'll have a lot more difficult time transitioning to a new programming language like JavaScript or something where everything is completely different. So always be learning, always be thinking, hey, I need to write a program. Well, I can throw this together in a few minutes and with PHP, but I wonder what it looks like in Python, right? Just take the opportunity there and learn a new programming language and solve this small problem on this small, with a new programming language. Certainly as you go on to CS3 and beyond, you'll be exposed to more and more programming languages. Not all of them you're going to use in depth for a full course, but certainly you should be learning about them. Because programming languages come and go. If several years ago, if you learned JavaScript or ECMA script pre-2015's version, you're going to be learning it again because of all the updates. You always need to be looking for again, exploring new languages. Otherwise, your skills become stagnant. And you'll find yourself 40 years from now programming Java, and maybe Java has the same status as COBOL does today, right? Very, very few jobs left in it or something. Who knows? I don't think that that'll be true with Java, but there are certainly languages out there that have come and died very, very quickly. Flash came and died very quickly, although it still has people that really like it. Coldfusion is another one that came along, burned brightly for a few years, and now it's completely gone, right? There are languages that are on the wane and that are disappearing now as we speak. There are languages that should disappear that will not disappear for the next 10, 15, 20 years, right? So nobody knows what's going to happen in the next 10, 15 years. Nobody can predict that. So the best strategy is to always be updating your own skill set. Hopefully you've gotten more experience with object-oriented programming, and you're now exposed to that paradigm in addition to the procedural style of C. Maybe next you'll want to pick up some more functional style programming language. I'd start with not with a pure functional programming language like Haskell or something, but my suggestion for your next programming language, if you don't know it already, is Python. Right? Which is very, very, the Pythonic way of doing things is very, very functional. Right? You've learned SQL, so you've got a relational database management systems under your belt now. And hopefully along the way you've picked up more Git skills, especially if you worked in a team with another pair. If you didn't use Git, I imagine that you were that you were fighting that collaboration all the time with. I can't even imagine how you got code back and forth. Maybe you didn't. Maybe it was you emailed it back and forth, or you put it in a box or something like that. That is not a solution at all. Floppy disks, yeah, or or thumbnail drives is what we should say, right? Hopefully you've experienced and you have perspective now building a larger project. And not most importantly, but also tangentially importantly, is that you've got exposure to technical writing in your first year at university. Hopefully you did well on that design document, that you took the advantage of those iterations and our constant feedback for that design document, and that will serve you well if you can write in a technical manner so that you're getting your point across to your audience without a lot of fluff, without a lot of detail. Anytime you need some detail, put in a diagram instead, right? Hopefully you've got some good experience there on that. Not that you'll always be putting together an IEEE 1160 or whatever the standard is design document. Maybe you will never do that in the rest of your life, but you'll certainly be doing some sort of a technical writing exercises on a daily basis. Whether or not it's as simple as an email or drafting a memo or maybe even creating a white paper justifying why we should go with this overall design going forward if you're a senior engineer, an architect, or something like that. A software architect is what I'm talking about, not building architect. Hopefully you have better appreciations. Hopefully you have a better understanding of technical debt, right, and eating your own dog food. If you had a bad design in, say, phase 1, you were stuck with that design in phase 2, phase 3, and going forward, right? You accrued some technical debt. By not having a good design up front, just slapping a bunch of code together, you had to live with that. You either had to live with that, in which case you were paying interest on that debt, fighting your own design, or you had to go back and redo it, right? In which case, now you're paying back that debt as far as your time is concerned. Remember, it's not Eric S. Raymond, but I don't know who gets credit for it, but the quote is, you have to find time to do it right, or you're going to have to find time to do it over, right? And that's what technical debt is. Bad practices, hopefully it's apparent now why they're bad practices. If you don't do design up front and you just start throwing code together, then you start to go down the wrong path. And then you have what we call throwing good money after bad, or what's the other way of putting it? Sunken cost fallacy. You go down the wrong direction. You've got a poor design. You just started throwing things together, and maybe it works a little bit. Maybe it's buggy. Maybe it's fragile. But there was not a well thought out design to begin with. And you realize that at some point and say, but I've written 100 lines of code, 1,000 lines of code, 2,000 lines of code, right? That in your mind you're thinking, I put a lot of time and effort into that. That has some value. I don't want to just throw that out, right? You should be comfortable with throwing that out now, because it wasn't a wasted exercise. You went down the wrong path and you realized that this was a bad design. Okay, let's go ahead and go back to the beginning. Throwing this out, that was a valuable experience because we've learned what not to do. Next time, we'll do it better. And so throwing it out and starting over and doing simpler code is probably going to be a lot better. Right? And hopefully you have an appreciation for that now. Usage of good test cases, test suites. The web grader is just there to grade. It's a black box testing. Hopefully you had you designed good test cases that served you well and that were good tests of whether or not your code was buggy. And a good test case can also be used to debug your code. If you have a good test case that fails for some reason, you can trace through your code knowing that it's wrong and how it's wrong, because you know the good input, you know the good output, but somewhere in between something went wrong. Hopefully you got over this in CS1, but poor variable names. And I put this in here just because, and not in this class, but in a class 2 years ago or so, a student came, they were having problems with their JDBC part. And they had picked up some bad practices from their CS1. For example, he had this flag variable that he called X. And so I was looking at it and I'm like, I can't read your code. What does X stand for? Talk to me here. Tell me what X stands for. And it was a flag variable, true or false, that, oh, it means that I should continue. I go, well, why didn't you call it that? So let's refactor this. And I just clicked on X and I called it what he said it was, to continue processing or something like that. And I said, now look at your code again, and look at your while loop. He was stuck in an infinite loop. Look at your while loop. And it was completely the opposite of what he expected it to be, because he had not named his variables correctly. Something very, very simple that you should never pick up as a bad habit in CS1, that carried over into CS2, and he'd gone down the wrong path completely, right? So hopefully you're now getting a greater appreciation of those good habits that we tried to instill in you in CS1. Some people may have over-engineered things. Remember the KISS principle, keep it simple, right? Bad database design, hopefully that became apparent. If you had a poor database design in phase 4 or whatever it was, you were fighting that database design because a lot of people realized, wait a second, I've got invoices and I've got products, I need to have a many-to-many relationship there. Some people didn't put that in their database design. And when they went to actually code it and start working with it, they realized that, and they had to go back and fix it. Again, you have to find time to do it right, or you're going to have to find time to do it over. Hopefully you have a better appreciation for a larger scope of a project, working, coordinating in teams, etc. Overall, hopefully you are better coders, better designers going forward. These were the skills objectives for this course that were in the syllabus. Again, hopefully you're able to pick up more easily a third, fourth, fifth, sixth programming language. Now that you've seen a couple of them, it should be easy to pick up another one. It's just syntactical differences. You know the basics now, and in 2 different languages. A conditional, a loop. They all pretty much look the same in most programming languages. Right? Hopefully you're able to recognize, use, and design and appreciate programs with an object-oriented flavor. Remember, one of the themes of this course is that at the end of CS1, you can take a problem and you can design a top-down solution, meaning that you can take this problem and you can start breaking it up into smaller and smaller pieces until the piece is so small that you can write a function to do it, or a function already exists to do it. And you put those pieces together and you've solved the problem overall. From the CS2 perspective, you start in the opposite direction. You start at the bottom. What class do I need to define to model this thing over here? What class do I need to define to model this thing over here? And how do I bring them together to interact? You're going from the bottom up. What off-the-shelf solution can I pull? What data structure can I pull off the shelf to solve this problem for me and get 90% of my problem solved? Right? And those are the kinds of questions that you ask at the end of CS2. Remember Eric S. Raymond? Smart data structures and dumb code work a lot better than the other way around. That was in the Cathedral and the Bazaar. It's a series of essays, and if there's anything approaching the philosophy of software design or software engineering or whatever you want to call it, that would be the book, right? And so if you're interested in philosophy and if you're interested in software development, then I'd encourage you to read that book or read that series of essays. Again, by the end of this course, you should be asking your bottom-up questions first. What do I need to model? How can I model it? And how do those models interact with each other? What data structures can you use? The big takeaway is that you may have done some things wrong or a lot of things poorly, but it doesn't matter, because next time you do them, you'll do them better. Right? You're always going to face this issue. Take some of your first programs that you wrote in CS1 in the last semester, less than a year ago. Look at your code and think, would I have written that same thing today? Probably not. You will always and forever be embarrassed by something you did last year, 5 years ago, 10 years ago, right? Because you are always improving your skills. Okay? So that's the big takeaway. There are some pre-final stats here if you want them. This does not include the final assignments. Assignment 7 we're still grading that. Assignment 8, of course, you have to turn that in on Thursday. If you want to do either bonus, remember that those have to be done this week as well, or the final exam. But the final exam is only about 5% of your grade, I forget. But in the main section, we had at the beginning 107 enrolled. Remember, 18 out of 99 have finished that course evaluation, so get that up to 100% for that 5% bonus. Currently, if we were to end the course today, 48 people, so nearly 50%, would be getting an A or better. And I didn't pull the stats, but I think that there were 5 or 6 people that were already getting more than 100% because of all the bonus that's available. There would be 25 Bs, 12 Cs, 11 less than, that should read less than Ds, sorry, less than Cs, and then 11 withdrawn. The interesting thing about the withdrawn is that I pulled the data. They weren't doing poorly. So I'd really like to know if they're still out there watching these videos, why did they withdraw? A good half of them were receiving A's at the time that they withdrew. And I suspect that it's just, this isn't something that they wanted to do anymore, which is completely fine, right? Computer science is not for everybody. Math is not for everybody. Political science is not for everybody. It's important that you find what is right for you, right? I'm not going to argue that, no, you need to be in computer science. Computer science is the best thing. You'll never get a job if you go over and do basket weaving or whatever. Well, that's true, but we don't have that major, right? But that's also, in a sense, not true. If you look at the software engineers of today, a good chunk of them don't even have degrees. They took an alternate path. They went through, say, Code Camp, and they improved their skills iteratively. Some are self-taught. Some went to 2-year institutions. Some are just entrepreneurs and made their own stuff. They're self-taught and they're financially successful, right? There are many different paths to a career in software development, software engineering, whatever you want to do. And frankly, you can change careers too. College, when you choose a major in college, unfortunately, a lot of people have a thought that that's what I'm going to be doing for the rest of my life. And that's not really true. Lots of people change careers. Lots of people transition from one career to another, or in the same area, right? You could be developing software for the next 20 years, and then at some point, you find yourself, wait, I'm not developing software anymore. What am I? I'm a manager of software engineers, right? And that's one path. Right? There are many different paths that you can take. So I'm not negative on those who withdraw, especially if they withdrew for a good reason. If they withdrew for a bad reason, then I would definitely want to hear that, right? But if they found what they're looking for, then awesome. Then it was still a success. In putting this in context, that's a 20.5% DFW rate. That's one metric that can be used. That is, how many people get a D or an F, and so basically don't get credit for the course. A C and above is okay for most majors. Computer engineers, you need a C+. So there you go. Hopefully that is changing as well, though. Ultimately, we may lower that. But anyway, that's a 20.5% DFW rate. Historically, at least over the last 5 years, the DFW rate for this course has been more like 28 to 30%. So it is, I view that as a good thing. In fact, I wrote up a white paper response to, and I think that it was the revamp of CS1 that directly led to these much better numbers. But it's still very high, 20%. Like one-fifth of the folks were not successful in this course. How can we do better? I'd like to hear from you. Right? The final exam is on for this section is on Thursday, May 2nd, from 3:30 to 5:30. I wish it were earlier, but that's our time. And I can't, if you need different accommodations, then you can talk to me and we can come up with a solution. It'll be right here in Henslick 124. I think that the only courses that actually change their room are like the large math classes or whatever, and they just simply cannot hold that many people. And so they might change their rooms, but this room is not changed. It's right here, that 3:30 to 5:30. The format is multiple choice. It will be comprehensive, but there will be far many more questions on the post-midterm stuff from JDBC on. There will be maybe 5-10 questions on pre-midterm stuff, but the vast majority of it will be on post-midterm stuff. You'll have 2 full hours, so 120 minutes. I'm only going to throw maybe 50, 60 questions at you at most. and I'd like to even cut that down. We've got chair interviews throughout that week next week. So I will have proctors here. Some of the LAs or maybe GTAs will be in here proctoring. I will not be here directly, but I will be available throughout the week next week. If you want to come and pick up your assignment 8, since it's a physical copy, whenever we're done with those, you can have those. It's open book, open note, open computer, just like all of my exams, because it's really not memorization stuff, right? I've attended scores of professional development seminars on teaching, and the first thing that always comes up is Bloom's taxonomy, if you've ever heard of it. And way down here at the bottom is memorization, and way up here at the top is comprehensive or application or something like that. And I've never understood why any instructor would be down here at the memorization level. Who cares, right? Everybody has devices they can look up. They can look up what the derivative of sine is in a matter of seconds, right? So that's not really testing anything. It's not really testing whether or not you can cram 5 minutes beforehand and remember what the derivative of sine is. And spoiler alert, I don't remember what the derivative of sine is. It's either positive or negative cosine, but I don't know, right? So that's the final exam. Let me go ahead and switch over here, and let's remind ourselves. Does somebody want to tell me what it was? Positive? Okay, thank you. So let's remind ourselves of the topics that we've gone through. All right. In the first few weeks, we introduced Java. Right? So it's very fair to ask general Java questions. Java virtual machine, the garbage collection, stuff like that, right? Or what collection would you want, et cetera, right? Java. Then what did we do next? We did object-oriented programming, right? With the 4 big pillars, 5 if you include objects. Right? What were the 4 pillars? Abstraction, encapsulation. Both, and this is not just limited to object-oriented programming, by the way. You have abstraction, you have encapsulation in even procedural languages like C. You just have weak encapsulation because you don't have the protection of data. You have forms of polymorphism. You could also call that weak polymorphism in C. You just have the generic void pointer, right? And then you have one sorting function that can sort anything that you want, right? Encapsulation, what was the other one? Inheritance. And you don't really have that in a non-object-oriented programming language like, say, Java. Right? So we went through Java, we went through OOP. We did databases, which included, basic SQL, right? Normalization, and, of course, programmatically accessing your data, so JDBC. JDBC, right? And the basics of programmatically accessing a database and working with a database. What do we do after that? Lists and list-based data structures, including array lists, or array-based lists, linked lists. And we use those to do stacks and queues and many variations. Right? For example, a deck, a double-ended queue that can be used to implement a stack, or it can be used to implement a queue. You've got priority queues, right, et cetera. So lots of variations on just very simple list data structures. What did we do after that? Algorithms and analysis. Right? We've got pseudocode. The 5 steps of analysis, which are identify the input size, identify the elementary operation, Analyze how many times the elementary operation is executed with respect to the input size. In other words, come up with a function, t sub n, f of n, whatever. And then 5, provide a big O asymptotic characterization of it. All right? And you're doing that hopefully right now on your assignment. Okay? What do we do after that? The final one was, there was 1, 2, 3, 4, 5, 6 modules that we called them. Trees and tree-based data structures. So you can do, pre, post, in order traversals. You can, for general binary trees, you've got binary search trees, right? BSTs. You've got heaps. Right? So that was the course in a nutshell. And all of these topics could be available on the final exam. Right? Again, heavily towards post-midterm stuff over here. Pre-midterm stuff will be there, but I don't know, maybe 20% of the questions will be over here, 80% of the questions will be over here. Right? It's all randomized anyway. Right? Any questions? No? Then, final reminder, make sure that you're filling out that course evaluation before the exam date. Again, I won't know who is filling it out. That's why I give the completion bonus. That if you have, I'll never know who fills them out. So I can't just give bonus to people who actually do it. It has to be a collective thing. Whatever percent sit the final over, and whatever percent fill out the course evaluation times 5%.